This is the Chapter 4 Part B review video. I'm going to start out by going through these first 6 problems, then I'll kind of shift the paper up so we can see the rest of them more clearly. So for number 1, I'm just being asked to simplify the expression. And the first thing that I see is this square root -9, which I know I'm not allowed to have because that contains a negative underneath the exponent. So I know that I have to change that. I'm going to leave it as 4 plus 5i radical 9. So I got rid of the negative underneath my radical by taking out an I, an imaginary number. Now I can simplify it even further because I know that the square root of 9 is actually equal to the value 3. So I'm going to take my 4, bring it down. Now my 5 that's already out here, this right here, and this 3 that's coming out, it's going to have to multiply. So I end up with 15i. 4 plus 15i. Now in the second problem, again, I see this negative underneath my radical. So I'm going to simplify that. I get I square root of 25 times 3 minus I. But I know that the square root of 25, this right here, is actually equal to 5. So I have 5i times 3 minus I. Now in order to simplify that, I need to do some distribution. I get 15i minus 5i squared. But since I know that I squared is equal to -1, then I actually have 15i minus 5 times -1, which is really just plus 5. So I'm going to go back and erase that. So my -5i squared changed to a plus 5 because this I squared is equal to -1. So that is your answer for number 2. For problem 3, I see that I'm just subtracting these two things, but I do have to be careful because there is that negative there. So remember, you're always going to distribute the negative into that second set of parentheses. So I'm going to rewrite my problem as 8 plus 2i minus 3 plus 4i. Now all I have to do is combine like terms. So I see that my 8 and my -3 can come together, and they become 5. And my 2i and my 4i come together, and they become 6i. So my answer is 5 plus 6i. For number 4, again, I have a negative underneath the square root, which is not allowed. So the first thing I have to do is pull my I out to the front. But then I think 28 can be simplified. So I'm going to have to use Joe's method here. So I take my 28, I'm going to divide by 2, I get 14. Divide by 2, I get 7. 7 isn't divisible by 2 or 3 or 5, but it is divisible by 7, and I get 1. Sorry, that doesn't really look like a 1. Okay, so now I have this group of two 2's that can circle up, which means they get to come outside of my square root with my I, but my 7 has to stay under. Because the 7 could not pair up with anybody, he has to stay underneath the radical. And so that's your answer. Okay, number 5. I see multiplication is happening because there's these two sets of parentheses with no symbol in between them, which implies that I'm multiplying. And I know that I'm going to have to be using something kind of like what we did when we were factoring. So I'm looking at double distribution. So let's go ahead. We're going to start with our 3 coming to our 5, which gives us 15. Our 3 to our -2 gives us -6i. Our 4i to our 5 gives us plus 20i. And our 4i to our -2i gives us -8i squared. Okay, so I have to go through and reduce some things. First of all, I see that my -6i plus 20i can be rewritten as plus 14i because I combine those two things together. But also, I have an I squared here, which remember is the same as -1. So what is -8 times -1? Well, it's just plus 8. And then the last thing we have to do is take our 8 and our 15, combine them together. So I get 23 plus 14i is my completely simplified answer. Now this last problem, number 6, we see that we have a fraction, so there's division happening, but we have this I in the denominator, which isn't allowed. So we need to get rid of that. We're going to do something called rationalizing, and we're going to do that by multiplying by our conjugate, which remember is just going to be the opposite of what we have in the bottom. So since this is 3i, we're going to use negative 3i on top and bottom. If this was 15i, we would use negative 15i. If this was 1 plus 3i, we would use 1 minus 3i. We went over this in class yesterday and the day before. So what I'm going to do now is go through and actually multiply these things out. When I multiply on top, I'm distributing, so I get negative 6i plus 12i squared. And on bottom, if I multiply those two things together, I get negative 9i squared. Now remember, your I squared is actually equal to negative 1. So when I replace those with negative 1, I get negative 6i minus 12. And on the bottom, I get just a 9. Now I see that I can do some division. I have 6, 12, and 9, all divisible by the number 3. So I'm going to divide all of those by the number 3. And I get negative 2i minus 4 over 3, which is almost my answer. But I want you to just please go through and put that in the proper form, which is having your I at the back. So negative 4 minus 2i over 3 would be your final answer. Okay, so now I'm going to slide this up a bit so we can see the rest of the problems here. Let me see if I can erase that little spot. Nope. Okay. All right, what I'm doing here for 7, 8, 9, and 10 is using the quadratic formula. So the first thing I'm going to do is I'm going to shrink this page up and move it out of the way. Make sure that you guys know what the quadratic formula is. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. That is something that you absolutely must know for tomorrow. If you do not know that, then you are really going to struggle with this test. So please make sure that you know that. Negative b plus or minus square root b squared minus 4ac all over 2a. If you want, you can go on YouTube and you can search for different songs, or you can think about our story with the boy in the radical party. The negative boy couldn't decide whether or not to go to the radical party. So that square boy missed out on 4 awesome chicks, and it was all over by 2 a.m. So you could also remember that story to help you with this. Okay, so let me now bring our page back in. I want this to go away though. So let's see if we can delete this. And now we're going to bring our page back in. I'm going to make it a little bit bigger. So 7, 8, 9, and 10. I'm going to go ahead and start with number 7. I need to first make sure that it's in standard form, and it is. So I'm going to identify what my A, my B, and my C are. A is 1, B is negative 10, and C is 21. And remember, that's just taking the coefficients from in front of your x squared, your x, and then the thing by itself, as long as it's equal to 0, which in this case, it is. All right, so now that I've got A, B, and C, I'm just going to plug into my formula. So x equals the opposite of B. So my B is negative 10 here, so I'm just going to put down the number 10. Opposite of B plus or minus the square root of B squared minus 4AC. And And remember, we're going to just plug things in parentheses. All over 2a. All right, now I need to start reducing. The first thing I'm going to reduce is this here, which remember is our discriminant. You guys got so good at reducing that. So I'm going to figure out what my discriminant is. I have 10 squared, which is 100, and I'm subtracting 21 times 4. So I get 16. So let's rewrite this and simplified. This is equal to 10 plus or minus the square root of 16 over 2. But I know that the square root of 16 is 4, so I'm going to rewrite it again. 10 plus or minus 4 over 2. Now remember, I have two answers here. I have the positive case and the negative case. So I have 10 plus 4 over 2. I have 10 minus 4 over 2. Oops. Over 2. So this is equal to 14 over 2, which is equal to 7. So that's one of my answers. And this is equal to 6 over 2, which is 3. So x equals either 7 or x equals 3. Those are my two answers for that first problem. All right, so let's go ahead and look at number 8. First of all, number 8 is not in standard form, so I need to make sure that I put it in standard form by moving this 9x to the other side. So I'm going to rewrite my problem. I get 2x squared minus 9x plus 10 equals 0. And now I'm going to identify my A, my B, and my C. A is 2, B is negative 9, and C is 10. After I identify what those are, I have to plug it into my quadratic formula. So x equals opposite of B, so opposite of negative 9 is positive 9, plus or minus the square root of B squared minus 4AC, all over 2A. Okay, now remember, we're going to go ahead and we're going to simplify our discriminant first. So negative 9 squared is going to give me 81. And remember, you can put this straight into your calculator. Minus 4 times 2 times 10. So I get x equals 9 plus or minus the square root of 1 over 2 times 2 is 4. Well, I know that the square root of 1 is really just the number 1, so I get 9 plus or minus 1 over 4. I'm going to break that up into my positive and my negative. And then when I actually work out those numbers, here I get 10 over 4, which is really 5 over 2 when I simplify it. And here I get 8 over 4, which is really 2 when I simplify it. So those are my two values for x. Okay, so we're on to number 9. I see that I do have standard form here, so I'm going to jump right in and start identifying A, B, and C. Okay, and then I'm going to plug it into my quadratic formula. So opposite of B is 6 plus or minus square root B squared minus 4AC all over 2A. Okay, when I calculate my discriminant, I get, oh wow, my discriminant's 432. So x equals 6 plus or minus the square root of 432 all over 2 times 9 gives me 18. Okay, so we need to pause for just a second because we have to do Joe's method on this 432. So I'm going to shrink this up and move it over so we can do Joe's method here on the side. we've got 432. Okay, divide it by 2. I get 216. Divided by 2, I get 108. Divided by 2, I get 54. Divided by 2 gives me 27. 27 I know is not divisible by 2, but it is divisible by 3, which gives me 9, which is also divisible by 3, which gives me 3, which is also divisible by 3, which gives me my 1. Now I have to go back up and circle things into groups of 2. I got a lot going on there. Okay, so now what gets to come out is 2 times 2 times 3. So 2 times 2 is 4 times 3. A 12 gets to come out. 12 gets to come out. And then we've got our radical 3 having to remain under. So I can simplify that on our piece of paper, that square root of radical 432 to 12 radical 3. So let me erase this. And then I'm going to make our paper bigger again. And 12 radical 3 is what we said we could replace this with. So x equals 6 plus or minus 12 radical 3, 12, over 8. Oh, 18, wow. Okay, and now I have to look. I see 6, 12, and 18. These three numbers here are all divisible by the value 3. These three numbers all have to be divisible by the same number. Then I can do that. So we're going to take all of those and we're going to divide them all by 3, which gives me 2 plus or minus 4 radical 3 over 6. Oh, darn, I guess I could have divided by something bigger from the very get-go. Let's go back and let's do that. I'm going to go back. I could have just continued on. Okay, I could have just continued and just divided out another 2. But I wanted you to see that, hey, I can't just divide by 3. I could also, from the very beginning, divide by 6. So I get x equals 1 plus or minus 2 radical 3 over 3. Now you can leave your answer just like that, or you can break it down into your 2 positive and negative answers. One would be 1 plus 2 radical 3 over 3, and the other would be 1 minus 2 radical 3 over 3. Okay, number 10. So again, I have something equal to 0, so I'm just going to jump right in to my A, my B, and my C, and I'm going to plug them in again. X equals opposite of B, plus or minus square root B squared minus 4AC all over 2A. All right, calculate your discriminant. Oh boy. Okay, so this is an interesting problem because when I put that into my calculator, this discriminant right here, what I get is negative 8. So x equals negative 8 plus or minus square root of negative 8 over 4. So remember, we're not allowed to have a negative underneath our radical. So what that means is I have to take out an I. So x equals negative 8 plus or minus I square root of 8. And that square root of 8 we need to do Joe's method on. And I see I can bring out a group of 2's. So I'm simplifying it even more. So x equals negative 8 plus or minus a group of 2's comes out with my I, and one of my 2's is just left under by itself over 4. Now I'm looking at my 8, my 2, my 4. I see they're all divisible by 2. So I go back in, I divide all of those by 2, and I get x is equal to negative 4 plus or minus I radical 2 over 2. So that is your final answer. You can then break it down into your plus and your minus options. Negative 4 plus I radical 2 over 2, and negative 4 minus I radical 2 over 2. All right, so I'm going to shift the paper a little bit more because we need to be doing 11, 12, and 13. And here, we're being asked to find the discriminant and then determine the number of real solutions. So if you remember, discriminant is just that one part under the square root, so only b squared minus 4ac. So first thing we're going to do is identify our a, our b, and our c, and then plug them in there. So b squared minus 4ac. And remember, you can plug this straight into your calculator. When I do that, I get 0. So my discriminant is 0, which tells me I have one real solution. Now we move on to number 12. Again, we do have standard forms, so we're good to go. We can just jump in and identify our A, our B, and our C, and plug it in. B squared minus 4AC. I'm going to plug that into my calculator, and I get negative 44. So the value of my discriminant is negative 44. When I have a negative discriminant, that tells me I have no real solutions. No real solutions when I have a negative discriminant. So now we look at 13, which is our last problem. And again, we do have standard form. So A is equal to negative 2, B is equal to negative 5, and C is equal to 1. When I plug in b squared minus 4ac, and I plug that into my calculator just as it is there with all my parentheses and everything. And what I end up getting is 33. So because that is a positive discriminant, I know I have two real solutions. Now if I look at this next part right here, it says sketch a possible graph. Well, I just have to think about how many real solutions I have. So let me first draw in 3 just like coordinate planes, rough sketches. Now remember that for every solution I have, that's how many times it crosses my x-axis. So if I pick this first one here, I need to have one real solution, which means my function needs to touch that x-axis one time. So if I need something to touch my x-axis one time, I'm just going to touch it and go right back up. Remember, all of these are going to be parabolas, and I'm looking for the number of times they touch the x-axis. So for my second one, if I want no real solutions, my function can't ever touch the x-axis. But for my third example, if I want 2 real solutions, I have to be able to touch my x-axis 2 times. So these are 3 possible sketches of graphs that are going to represent those 1 real solution, no real solution, and 2 real solution examples. Okay, so on the back of this review, what I did for you is I just typed out definitions for each of these words that are in the word box. So I went through each one. The only one that I need to write in is the quadratic formula. So what I'm going to do is slide up a little bit. For these first 4, 13 through 16, if you need to copy them down, go ahead and pause the screen. I'm going to go through them quickly. For the first one, zeros of a function are what you're actually finding when you solve the quadratic equation. If you think about it, we talked about this in class. When we solve, we're getting an answer, which we learned answer can also be explained by roots, zeros, solutions. Any of those words work. So zeros of the function. Complex numbers, we have this in our notes, is the set made up by imaginary and real numbers together. Imaginary and real numbers together, when they're together, that's complex. I have complex numbers. An imaginary number is the complex number whose square is -1, because remember, we have I squared equals -1. The complex number whose square is -1 is imaginary number. Okay, factoring. Factoring is just rewriting an expression as a product of its factors. If I'm rewriting it as a product of its factors, I have factored it. I was factoring. Standard form is just ax squared plus bx plus c. Usually, lately, we see it equal to 0. That's standard form. And remember, we always have to have standard form when we're using the quadratic formula and we're identifying our a, our b, our c, or if we're finding the discriminant. So speaking of the quadratic formula, this is something you have to have memorized. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. That is your quadratic formula. And then we've got two more. The zero product property. All this says is if I have two numbers that multiply to be 0, then one of those two numbers must be 0. So product means multiplication. The zero product property says if I have two things multiplying to 0, then one of them must be 0. And our last thing is discriminant. Sorry for the typo here. That should be the value of the expression b squared minus 4ac. You guys were really good at the discriminant, so just know discriminant is the value of b squared minus 4ac. So go ahead, you can rewind, you can copy these down, whatever you need to do. This is the vocab that you need to be able to know for the test. I promise you, this will be on there. Please know these vocab words and their definitions.